Kia ora team and welcome to another online tutorial. Today we're going to be talking about features of oscillating systems, working on our new topic of simple harmonic motion. Okay, so first off, what does it mean to be oscillating? Some of us may not even know what this word means, and that's cool. So I'm going to quickly define that. An oscillating object is an object that's going to move back and forth repeatedly, typically about a central position, in which we call an equilibrium. Okay, so I've marked that here. A central point at which we move about, or an object moves about, and the oscillation would be moving back and forth. Okay. Common examples are often pendulums and masses bouncing on a spring. We have our displacement, which is the distance the object has moved from equilibrium or from its central position. And this is also, think about wave systems, our amplitude. Okay. Again, our center position is known as our equilibrium, and a single oscillation is one complete cycle. So if we start here, we have to go from one side back to the other, and that's one oscillation. So with that in mind, let's quickly touch on frequency and period, thinking back to level 2 physics. Frequency, F, is the number of oscillations that occur per second and is measured in hertz, okay? With period, capital T, the time taken to complete a single oscillation and is measured in seconds. Again, the period, the time taken to complete one single oscillation. Okay. Now, these two have an inversely proportional relationship. What does that mean? F is equal to 1 over T, meaning that the frequency is proportional to the inverse of period, and period T equals 1 over F, meaning that our period is proportional to the inverse of frequency. What does that mean? That means if our period goes up, our frequency goes down, or if our frequency goes up, our period goes down. Okay? Makes sense, seeing as frequency is the number of oscillations per second, and period is the time taken for a single oscillation. Looking at pendulums, if we assume that friction is negligible, or energy is going to be conserved. That means when we have a displaced object, okay, which will have EP, that energy potential will be converted fully or transformed into EK, which will then be transformed further into EP without any energy being lost, assuming friction is negligible or non-existent. Okay? So our energy potential will equal EK, which will again equal our energy potential. If we're thinking about the forces acting on, as well as acceleration and velocity of a pendulum, okay, when our displacement is the greatest and our object has a lot of EP, we will have high acceleration. Okay. As that EP is transferred into kinetic energy, we will have high velocity, low acceleration. As that EP is transferred into, as that EK is transferred into EP, our velocity will become 0, our energy potential will become higher. We again will get a higher rate of acceleration due to gravity, producing a velocity, meaning that in our central position, we have our highest velocity. At our max displacement, we have effectively no velocity, but greater acceleration, because at this point, our force is acting perpendicular or 90 degrees to the system, or our equilibrium position. It should be said that this is assumed when we have a closed system with no external forces. At maximum displacement, forces acting on our pendulum bob will be acting 90 degrees to our equilibrium or system, and we will have our greatest acceleration. Cool. Hopefully this has been helpful, team, running you through features of an oscillating system. Remember, frequency is inversely proportional to period, that an object when moving through the equilibrium is going to have the greatest velocity, but the least acceleration when all its energy is energy kinetic. When an object is at its maximum displacement, it is going to have its most minimum or zero velocity, but its greatest force and acceleration. And that assuming friction is negligible, energy is conserved, EP will equal EK, which again will equal EP in the system when that system is closed and has no external forces acting upon it. Hopefully this helps you to get out there and get into some physics. Good luck and have a lovely day.